Welcome to Textile Update, the podcast where we can share our passion for textiles, fibers, and yarns. This is Gwendolyn Hustvedt. This is the first in two podcasts that focus on how we take naturally occurring or synthetic polymers and make them into fibers. So we're talking about manufactured fibers, fibers that do not occur in nature, but that we have actually manufactured using our manual dexterity and manipulated them into being fibers. We've reached the definitively 20th century portion of our conversation. The fact is that everything we've learned about silk or wool or linen or cotton, we could have learned 100 years ago and would have been substantially the same. Partly because we haven't talked about things like genetic modification, we haven't talked about advances like enzyme reading, but there's something to be said for just sort of learning things that are just substantially true and have been true for a very long time. Now, however, we're turning our sights on the manufacturing of fibers. And so it's important to contextualize that before we figured out, and I'm going to say we a lot here, and by we I mean textile scientists or people who were interested in changing the textile industry. I don't mean we, people who are listening to the podcast. I don't mean we, Western civilization. I just mean we, the people who are interested in making fibers. So before we developed processes to manufacture fibers, there was no difference between natural and synthetic or natural and manufactured. So this attempt to understand how we would categorize fibers is the result of development of 20th century materials. So in fact, I want to reiterate that fibers come in two main categories: natural and manufactured. Natural fibers are naturally occurring as fibers, right? Naturally, they're fibers. And it's partly because until we invented a way to make fibers, it never occurred to us that we could take a tree, chop it down, put it through a chipper, use some of the pulp to make paper, and use the waste pulp that was left over to make a fiber. We didn't talk about that because it just wasn't a thing. So natural fibers are naturally occurring as fibers, and because they're naturally occurring as fibers, they use polymers that occur naturally. Manufactured fibers, on the other hand, have two important subcategories. The first are what we call regenerated fibers, which are fibers that are manufactured. These are made in a factory somewhere. Didn't chop down a stalk of bamboo and pull the fibers out. We chopped down a stalk of bamboo, put it in a chipper, made paper out of most of it, and made rayon, for example, out of the waste pulp that was left. So it is absolutely made in a factory, absolutely requires chemicals, absolutely produces pollution, requires labor, right? We're not saying that naturally produced fibers are innocent, right? Because of course there's all of the agricultural byproducts to think of. But regenerated fibers are made from the same polymers that naturally occurring fibers are made from, but the fibers themselves have been manufactured. So we can take protein from agricultural waste, for example, leftover feathers, or it's going to get a little gross here, but blood, right? The skins of shrimp, the mash that's left over after we squeeze the some of the goodness out of soybeans, right? So a number of things that might have protein in it. We can then polymerize those amino acids and make polymers, and we can then extrude them as fibers. We can take the waste from paper manufacturing, as I mentioned, and make it into a fiber. And then the other major category of manufactured fibers are where we use a polymer we invented. It is not a naturally occurring polymer, and the fiber is manufactured. And there the interesting thing is that we have to think about what else that polymer could have been, right? So polyester could be a water bottle, or it could be a suit, right? Because our choice is, did we make it into a fiber or did we make it into a chair? Right? Did we make it into a fiber? Or did we make it into contact lenses? Right? So we had a choice about its form because we're in charge of the manufacturing. So I think that's a really important thing to understand about manufacturing fibers. Now, you heard me mention the word extrusion, and then I sort of pulled back briefly because I realized I wanted to talk to you a little bit about extrusion. Breakfast cereal is extruded. Cheetos are extruded. Really, in a lot of ways, extrusion is very much a 20th century story. Have you ever played with, as a kid, with Play-Doh? And maybe you had that little kit that the Play-Doh came with where you could put the Play-Doh in a little box and then press down on the top of the box with a little handle that closed off the Play-Doh inside the box. And on one side of the box, you had slid in a plate that had maybe a star shape on it. And as you press down on the top of the box, the Play-Doh was squeezed out through the star-shaped hole. That's extrusion. Extrusion is an idea that we actually got from silkworms. Silkworms take a sack full of protein inside their bodies and then squeeze it and extrude the protein out the orifices in their head. And so extrusion is the manufacturing process through which we make polymers, whether they're naturally occurring or synthetic polymers, into fibers. So we have a chamber where we have the polymer liquefied in some way, right? A goo of some type. I'm going to tell you right now the technical name for that liquefied goo is dope. So I'm going to say dope a lot now. Sorry, but that's scientifically what it's called. So the dope is squeezed out of tiny little holes in a piece that's called the spinneret. And the spinneret looks kind of like a shower head. And then depending on the size and shape of the holes in that shower head, that spinneret, we end up with different cross sections and diameters of the manufactured fibers. Again, whether they're made from naturally occurring polymers like cellulose or synthetic polymers like polyester, right? They're both extruded out the spinneret. Given that this is a point at which you probably want to look online for lots of diagrams and things, right? I'm trying to describe things as vividly as I can, knowing that you may or may not be looking at pictures, right? I'm going to now attempt to describe the three main methods of what we call chemical spinning. Now, we call it chemical spinning. One of the really sad things about fiber manufacturing from my perspective is that we lose this really fun and amazing vocabulary that we have with ancient fibers like linen. So we just start to reuse words in a lot of cases, or we just use a little modifier, right? So instead of coming up with a really fun name, like in the case of mercerization, we use the dude's name, right? So instead of calling melt spinning, Randolio, right? I just made that up, but we call it melt spinning, which just describes what it is, but is kind of not as fun. All right, I'm just going to say that up front. I'm a little disappointed in the lack of language creativity on the part of the scientists and industrialists who invented these methods. On the other hand, if you're learning about them, it sure does help make everything super clear because you can just be talking about something that describes itself when you name what you're talking about. So chemical spinning, to distinguish from mechanical spinning, which is the old-fashioned, spinning wheel. We'll learn about spinning when we get to yarn. So chemical spinning, which makes a fiber by extruding it. The dope is liquid in some way, gooey, dopey. And after the fiber is extruded, it must become hard enough that we can use it, right? So we think about there's a step where we take a material that's mostly a solid. Now, in the case of Rayon manufacturing, for example, the mostly solid is a tree. And we liquefy it by putting it through a wood chipper and adding a lot of chemicals after we, as we begin to make paper. Okay, but the liquefaction phase of, for example, olefin, which is a material invented in the 50s, very hydrophobic, used in a lot of non-wovens. Right, that material, we would take chips of it that had been shipped to the extrusion facility, the chemical spinning facility, the fiber manufacturing facility. These chips might look like little flakes or chocolate chips, and they'd be shipped in barrels or shipping containers from a factory somewhere that took the petroleum byproducts and turned them into the olefin, and then sort of roughly extruded it into chunks, right? Not into small fine fibers. And so we have that solid, whether it's chips or it's sawdust, and we liquefy it in some way. We extrude it and then we harden it. So that's kind of the standard how you make a fiber out of something, right? System. And then the differences come in how you liquefy it or how you harden it, right? So the first method that we can use in chemical spinning is called melt spun. I've already mentioned it. That's where we take the chips, the solid polymer, and we melt it. See how easy that was? And then we extrude it, and after we extrude it, we allow it to cool. Yeah, just like an opposite situation there. And so, for example, you could picture pouring chocolate chips in a saucepan, allowing them to melt, right? And then squeezing long strings of chocolate out the tip of a pastry bag, right, onto a cookie sheet, and then allowing them to cool. And then you'd have these like sticks of chocolate. So melt spinning, we use heat to liquefy, and then we use cold air to solidify. The next method is mostly called dry spinning or solvent spinning. I'll accept both answers when I talk with students. It's sometimes called dry spinning to contrast it with wet spinning. Because after even though the solvent is a chemical, right, when that liquefies it, right, then when it's extruded, the chemical just evaporates, the solvent evaporates, so there's no need for a second bath of water, which is what gives, a second bath of chemicals, which is what gives wet spinning its name. Bath of water. I love bathing, by the way. Bathing at rivers, bathing in bathtubs, bathing in jacuzzis, bathing in spas, bathing in the ocean, right? Bathing is amazing. All right, so sorry about bringing up bathing there when I mentioned a water bath. It would be a chemical bath. So solvent spinning, think of when, if you've ever visited a nail salon and had your tips filled, and for those of you who haven't, videos on YouTube you could watch of this if you wanted. The technician will take a powdered form of the acrylic, dip their brush into a solvent. The solvent dissolves the polymer into itself. They make the dope, like a little bead of gooey acrylic. They press it into the crack that's appeared between your cuticle and the plastic that the acrylic nail that's been glued to your nail bed, and then they smooth it with more of the solvent in order to make it into the proper shape. And then you simply hold it in front of a fan, and the solvent evaporates, releasing noxious fumes into the air, which are part of what makes visiting a nail salon unpleasant, right? So that's dry spinning because you just allow the resulting fiber to dry. You would use warm air in this case, if at all possible, in order to speed the evaporation of the solvent. So that really contrasts it with melt spinning that used cool air. And then the last method, wet spinning, involves liquefying the solid using chemicals. So we've got chips of wood. We need to get the cellulose out of the chips of wood. We'll use other chemicals to strip away things that aren't the wood. and to suspend those cellulose, little tiny short pieces of cellulose polymer in liquid. So we're not starting with a bath of sugar, right, of glucose, and then allowing it to polymerize. We're starting with already existing short chains of cellulose that we're going to try to encourage to connect with each other. Because the fibers that need melt spinning are very fragile, this is something important to remember later when we think about their care and their properties. They're very fragile. We can't just extrude them into the air. They would stick together. They would break. They're just too fragile, right? So we actually extrude them into a bath of other chemicals, and these other chemicals actually coagulate the fiber. So they actually pull the chemicals that liquefied the polymers in the first place out of the fiber, right, and allow the fiber to sort of settle in with just polymers inside, and so it's become, it coagulates in the same way that sort of like gelatin might coagulate, right? And so if you've ever seen what is this called, this type of culinary art? Oh, I'm forgetting the word just now, but where they use a lot of chemicals to do really cool things, right? You might see people coagulating juice in a chemical bath in order to make little balls of juice. So this coagulation process very often takes place in a bath of chemicals. I've mentioned chemicals a lot with wet spinning. This is partly why textile scientists were so offended when people started making claims that rayon from bamboo was somehow eco-friendly, because we just knew its very existence was thanks to lots and lots of chemicals, and that those chemicals had to go somewhere, and that the fabrics were not being made the way that people imagined, which is just ripping fibers right out of a bamboo plant, like we might in the linen method, but that in fact lots of baths of chemicals were involved, that people were believing that fiber was eco-friendly simply because they were innocent of any education surrounding how fibers are manufactured. So those are the main steps. In the next podcast, we'll talk about what happens immediately after the fiber is hard enough to handle, and how we can immediately begin to modify the fiber in order to make it suitable for our desired end use.